Hey, welcome here. We are talking about solving absolute value equations and inequalities, section 6.4. So absolute value, you've heard that before, but what does that mean? Well, remember, first of all, it means the distance or number of steps to zero, and distance is always positive. No matter what direction on the number line you're going, if you're taking a step, that counts as one. If you go run 4 laps on the track, one direction, you ran a mile. If you run it the other direction, you still ran 1 mile. It's positive. The symbol that goes along with absolute value or distance to zero are these two big straight lines. Like here, the distance to zero of some number is 5. So that means that you could have been at 5 because that's 5 steps to zero, or you could have been at -5 because -5 stepping on the number line to zero is 5 steps. So for what values, what are my solutions where the distance to zero is 5? It's that. It's -5 and +5. And you can check it this way. The absolute value of -5 is 5. The absolute value of +5 is 5. So those are definitely my two correct answers. Now what we're going to start out doing today is modifying what's in here. Now there's some number, if I add 2 to it, the distance from 0 is 10 steps. So one solution is 8. And so I'm going to show you how you get that here. I'm going to show you the split right now. When you have an absolute value sign with some stuff in it, that's cool, but nothing else outside of it on the equals, on that side of the equal sign, we can do a split. We can go x plus 2 equals 10. Yes, I took away the absolute value sign. Doesn't solving this still get you that 8 that we know is one of the answers? Well, how do we get the second answer? We're going to take away the absolute value sign. So we're going to go x plus 2 equals, well, if I ended up on 10, that's 10 steps to 0. That's why 8 works here. 8 plus 2 gives me 10 steps to 0. What if we factored in the -10? That's like the opposite side of the number line. If I wanted to be 10 steps from 0, I could be at -10. So what number for x here, when I add 2, puts me at -10. Now you just solve this equation, just like we could have shown our work and solved this equation. This gives us 8, which is a solution. This gives us our other answer, the other solution, which would be, I think, -12 here. Subtract 2, x equals -12. Boom. So this is called a split. We drop the absolute value sign and set one equal to 10, or whatever this number is. We just drop it down. But then the other one, we drop the absolute value sign and we take the opposite of whatever this distance is. Let's try a little bit more of that. So here, we're going to isolate the absolute value term. Well, it is isolated. There's nothing else outside of the absolute value symbols here. We're going to rewrite the expression without the absolute value symbols. So we have 2x minus 3 equals 5. Now we're going to write the expression inside the absolute value sign that we're taking away again, but we're going to set it equal to the opposite value. So rewrite this expression again over here. I like to actually show arrows that I'm splitting this into two problems to give me my two solutions to the distance that makes it true. So 2x minus 3, boom, we write that completely equivalent. But then on the right side of the equal sign, or whatever that distance is, we're going to make opposite. So instead of 5, we're going to go -5. So we add 3. What's kind of cool, like you could solve these two equations all together because you're going to have to undo the same stuff to x. Like x is being subtracted by 3 here, so we have to add 3. Same thing over here because you're copying this expression of what's being done to x. Exactly the same. So if you want to do this kind of jazzy move, you could. You don't have to. If you just want to solve this left equation, by all means do it. So we get 2x equals 8. And over here we should get something different because we're not adding 3 to 5. We're adding 3 to -5. So we get -2 over there. But our undoing steps are going to be the same. What's being done to x now? We're multiplying it by 2, so we divide by 2. What's being done to x over here? It's being multiplied by 2, so we divide by 2. But over here we have 8 divided by 2, which is 4. And over here we have negative 2 divided by 2, which is negative 1. Those are my two solutions. Those are the two numbers that I could start at the number line. I could start at the number line that when I when I multiply 2 to it, remember we have to follow our order of operations when we simplify. When I multiply my two answers respectively, each individually by 2, and then subtract 3, I get 5 once I take the absolute value. Let's try it with this one right here. So negative 1, let's check that, because a lot of people don't like this second answer that I get, or the process. It kind of seems like magic. Well, let's take negative 2, let's take 2 times negative 1. That equals negative 2. Negative 2 minus 3 equals negative 5. So really what I'm trying to take here is the absolute value of negative 5. What's the absolute value of negative 5? 5. Boom. Let's try example number 2. Now step number 1 says isolate the absolute value term first. There's my absolute value term. There's some stuff inside it. That's cool. Nothing to worry about there. Is there anything else over there outside of it on that side of the equal sign? Yeah, there's the minusing 4. So I have to add 4. I have to isolate or undo the things that are outside of the absolute value sign. So we get the absolute value of 2x minus 5 equals 6. Step number 2 and 3 is really just what I call the split. So I'm going to drop the absolute value signs. And the first time I drop them, I basically just write down the equation the way it is without the symbols. Boom. For the second one, or the other one, I'm going to still drop the absolute value signs and write the same expression that was over here and that's over there without the signs. But then I'm going to take the opposite of what the distance is supposed to be. So it's going to be negative 6. So here we go. We're going to add 5 to solve for x over here. So we get 2x equals 11. Over here, if you want to, again, solve both kind of simultaneously. Now we get 2x equals, now you should get a different number here because this was 6 plus 5. This is negative 6 plus 5. Now solve for x, divide by 2. We get x equals 11 halves, or 5.5. Over here we get x equals negative 1.5. I'm going to check just this one right here. We really should check both answers and make sure it's true. But so I'm going to plug or substitute negative 1/2 into the original problem. This was my original problem. So remember to simplify within absolute value symbols first. So we get 2 times negative 1/2 is negative 1. Negative 1 minus 5 is negative 6. The absolute value of negative 6 is positive 6. What's 6 minus 4? It truly is 2. And does 2 equal 2? Yes, truth. That is the solution then, because it makes my equation true. And if you did 11 halves instead in place of negative 1/2, I think you would also find that it's the only other number out there that makes this absolute value equation perfectly true.